Boom. Yeah, let's do it. Okay, we're going to continue with lecture. This one was, it was missing multiple degrees here. It was missing x squared and x. We do have to make columns for it so that we can put zeros in. So voila. And so all the zeros are here. Let's just back up just real quickly here. And I'll let you guys try one.
It's not bad.
Miss Charlie. Okay, let's go for it. Let me let you guys try this yourself, and I'll let you go, and then let's see what we can do here. Can you divide 3x cubed plus 8x squared?
I can't. Can you read that?
Blind
Sorry,
X
I'm blind.
plus 2.
Is that x plus 2
Shut up,
or x
Charlie.
minus 2?
You sighted person.
3x cubed plus 8x squared plus 5x minus 7 by x plus 2.
Wait,
8x squared plus 5x minus 7?
I already
8x squared plus 5x plus 7?
And then
Minus
we're
7,
dividing-
sorry, minus 7, yes.
And then we're dividing by what then?
X plus 2. Let's see, let's dim the lights even further. Let's see if that helps.
Can we do it in like black, not red? I feel like the black helped last time.
Thank you so much. I just changed the color.
Okay.
So all yours goes first because you guys should be able to do it.
What's the rest of it?
All right, man, I did AC/DC. Right on. And then I understand writing on the desk is kind of fun, but if you want to leave your notes for later, that's the little problem.
Oh, no, I don't ever look at them, so I'm chilling.
Okay.
That's like admitting that to the math teacher.
I have a math tutor for a reason.
Okay.
I can do math, not perfectly.
Like, hey, what did you cover in class? I don't know.
No, notes don't ever help me. I never look back at my notes. I just retain information.
All right, real quick here, show of hands, how many are at least halfway done? At least halfway done. Boom, okay. So I'm gonna start real quick here. Those of you that are waiting for me, let's go for it. So it's always about leading term and leading term. It's always the front one to the front one. So the question is, what multiplies x to give you 3x cubed? I don't know, but I think it's 3x squared. Right, and you always put it at the end of the number. And so if that happens to be the case, we're going to multiply this times all this here. 3x squared times x gives you 3x cubed. 3x squared times 2 gives you a plus 6x squared. And I think what we do is we subtract. Even better yet, we add the opposites. This becomes a minus. This becomes a minus. Boom. Cool. That's gone. 8 and a negative 6 would make it 2x squared. And you bring down the next term. Don't forget the plus sign. And we do it all over again. So what multiplies x to give you 2x squared? 2x is perfect. Thank you. Okay, we erase the little arrows here. And boom, now it's this guy times this guy. So 2x times x gives you 2x squared, as we planned. 2x times 2 gives you a 4x. Subtract, forget that. Add the opposite. Boom and boom. And that guy better cancel, else you did something really, really wrong. X comes down, and the minus 7 is here now. And the party starts all over again. X times what gives you x? Yeah, positive. Don't forget you're going to put a plus 1 or a positive 1. It gives you a plus 1 here. So 1 times x is x. 1 times 2 is 2. Subtract, nah. Add opposites. Remainder is? I got -5 and -9. Which one it is? -9. -9 is the remainder. Done. Awesome. Okay. Cool. But hold on real quickly. If you think about this here, Notice the x cubed and the x squared and the x and the unit value. Now put your thinking caps on. You guys ready? The x cubed and the x squared and the x and the 7, or the unit value, those were just kind of to keep those columns together, right? That's the whole purpose we used them, right? I mean, it would have been the exact same thing if we just kept the 3 where it is and just erased all the x squareds and the x cubes and the x squareds. It's just about columns. So, long time ago. Oh, and then the other thing is this right here. Look at this. And notice that what we do is we always subtract, right? So 2 things here. How about if when we multiply through, right? When we multiply through, how about if we could just multiply already the negative inside it? So if we change the sign on this guy, we put the negative over here, and then we forget about the x's completely. We just make sure that we have columns for each designated row. We good? Or designated degree. So let's try this out. Let's try this out. I'm going to do example number 4 or for 5.
How do you show the remainder?
In black. Oh, sorry. We didn't finish out the problem here. I got too excited about this already here. So final answer is 3x squared plus 2x plus 1. And then it's, you could do a minus 9 if you like, but usually it's plus negative 9 is the remainder over your original divisor. And if you put a minus in front of the fraction, that's fine too. It's going to be a minus 9. Okay. Now let's get into the fun stuff here. Exercise 5, let's see, divide. The same thing. We're going to add an extra little piece at the end here. By x minus, or x plus 2, right? And I'm going to write using something called synthetic division.
This is the same problem.
Same problem, just a different way now. Synthetic division. And I would want to make sure I spelled synthetic division. Let's see. Let's decide if it's easier or not.
It's not.
It is supposed to be a shortcut. So here's what we do. We say to ourselves, you know, let's somehow I've got to keep that little negative on the inside here. So what we do is we do this. If this guy was solved for 0, what would x have to be? Negative 2. It would be negative 2, obviously. Okay, so we're going to take this negative 2. We're going to stick it out front of this guy. And we're going to do an upside down divide symbol like this. Whoa.
Go back to the other one.
And then what we're going to do, it'll be easy, just a second here. And then we're going to just place just the coefficients, just the numbers in front of your degrees. So 3 comes down, 8 comes down, 5 comes down, and negative 7. And all we do is we're going to add down. In this case, there's nothing to add, so that's 3. There's going to be another row right over here. We're going to add down, good? And we're going to multiply back up. So negative 2 times 3, negative 6. Adding down, 8 plus negative 6. 2. Take that guy and multiply up again. Add down. 1. Negative 2 times 1, multiply back up. Negative 2, there's, and the end is negative 9. Okay, let's see, back to our previous problem here. Whoa, that's cool. Absolutely, we can explain. So,
Not how, why?
why does it work? Sure.
Because of math. Math can never be explained. Math is just math.
You can explain all of that.
You know, I'm just trying.
Math better be explained or else we're doing something we don't know. Okay, the reason why it works, here it is. So when you do this one right here, notice when the little minus 2 at the end. Because what happens on the front is we're just trying to multiply to get to here, right? We're going to We multiply the front term just to get to the exact same as the front term. This little 2 at the end here, that controls the subtraction and additions all the way through. So notice the -6, the -4, and the -2. -6, -4, -2. Those are your multiplications. We good? So instead of multiplying it in and then saying, okay, now let's subtract. Now let's take the opposite. Yeah, it's all done in a single swoop right over here.
Who came up with this?
You know, I wanted to find out, never found out yet.
Luke Thomas is my favorite snack from the
Okay, awesome.
I know I love it.
So what happens here is we went from an x to the third polynomial and we went down to an x to the second polynomial. So the way we write it is this guy has to be now degree 2. So it's 3x squared plus 2x plus 1, right? Plus, oh, there's our remainder. In fact, some textbooks, what they do, they put a little box right here. And then just for you to know, okay, that's gonna be your remainder. That's gonna be your remainder. They put a little box there.
I like the other way. There's so much more confusing. How is this confusing? It's like simple addition.
Yeah, this seems way easier. Squared plus
Say again, any questions on this one? Dylan, did you have a question?
how do you get 3x squared plus 2x?
Sure. So since we started off with x to the third, synthetic division, all it does is it takes you 1 degree lower. So you know you're going to end up with degree 2. So you just take each one of these pieces. That's degree 2, that's degree 1, and that's your unit value now. Okay, just for practice, we good? Dylan, okay? Was that enough of a question? Did I answer your question? Okay. Exercise 6, let's go.
Can I squeeze the other way, or do I have to?
Just to practice this way.
The other way, I'm so bad at this.
You haven't even.
You did it
tried
one
this
time, kind of, sort of, not really.
Bruh.
We all did it one time.
Give it a
This one
check.
is
Ooh,
direct.
okay.
No. Me like.
Okay, so divide. I guess I should say divide.
But 19 negative 18 negative 16 is 72.
32.
30.
32, by x minus 2.
So it's plus 2.
Wait, so what, the number, do we do a +2 or a -2?
It's whatever this guy will equal. In this case, it's going to be a +2. 2 goes on the outside. Upside down division symbol. And let's plug in our values here. 9, negative 18, negative 16, 32. Oh, sure. Okay. Hey, let's go for it here. So all we're doing is we solve this for 0.
I thought it was a 19 or 9.
It's a 9.
Oh.
Okay, and then what we do is we just take each of the coefficients, just the numbers in front, and we bring them down. And then all we do is we add down, in case there's nothing to add with the 9, so that's just going to go straight down. And then we multiply back up. So add down, multiply back up. So added 9 down, we multiply back up, which makes 18. That's cool. Negative 18 plus 18 is 0. Add down, we multiply back up. What was that? Oh, that's going to be still 0, right? Adding down, negative 16 plus 0. Multiply back up. Add down, 0. And then if you want, I like to do this here. I like to put a box here because that tells me what my remainder is. My little boxes is my remainder. Cool. All right, Abe, are you unconfused?
No, yes, I got it.
You got it? Okay. So real quick, we've got to take a vote in just a second here. So I got no remainder. That's cool. You can do one of two things. You can go backwards through the number. If that's the remainder, that means this has to be the unit value, right? This is x to the 1, and that has to be x to the 2. So it becomes that right there. We good? You go the other way, saying, look, I went from x to the third. I know this has to be x squared now. That has to be x. That's my unit value. And you write in the coefficients. Dylan.
Is there any scenario where we cannot use
Perfect. Thank you so much, Dylan. The next step. This guy can only be used if this little guy over here is a linear term. So now,
It's a whole number, like it's not a fraction.
it's only to the 1 power. So if this was x squared minus 2, can't use it. This little piece right here.
Oh.
The divisor has to be linear, which means no exponents on the variable. So now let's actually define synthetic division.
How is my guess?
Okay, so real quick here, just a little note if we need to hear synthetic division can only be used if our divisor, number that we're dividing by, is a linear term. And again, linear term, just an example. Examples are x plus 4, x minus 7, x. Yeah, you can use fractions. It's still a linear term. You can use 1/2 if you like. That's fine. X plus 12. Those are all linear terms. We're good. So you can't have a square on the x. You can't be dividing by x cubed minus 4. That won't work. But x minus 4 would work. Okay. We are out of here 35 after? Okay. Okay, guys, talk to me here. Are we good with the synthetic division? Do we need more practice on it, or was that pretty cool? Okay, let's go. For synthetic division, there's not so much a formal definition because it's a process. Right? But I can give you a definition of the remainder theorem. Here it is. Let's do this one. The next one on the list is now this is a theorem, the remainder. So real quick here, if I'll do like this, if f of x is divided by x minus k, the remainder is r, which is also equal to f of k. So two theorems we're going to look through real quickly here, and then that's going to help us to really get to 2.5. No, 2.5 is the culmination. Yeah. So we're all doing this. We're doing all of this to get to 2.5. That's the like, ta-da, we've arrived at our top of that thing. 2.5 is the end of all your working from 2.1 to 2.2, 2.3, 2.4. So like, okay, that's why we are using all this stuff.
After that.
I think so, yeah. Okay, guys, let's talk about this here. Yeah, let's see. The question is this: if I'm dividing f of x by x minus k, it says my remainder is this r value is just the same thing as plugging in my k value. What? Let's go check this out. Let's see. So let's go back to our previous one. Example number 6. We'll do 7 right now, but example number 7. Here it is. What is the remainder? So not interested in the whole division schema. We good? What is the remainder if f of x 3x cubed plus 8x squared plus 5x minus 7 is divided by x plus 2? Question mark. Okay, we've done this before. I think it's exercise number 5 or 4 maybe. But here it is. Who cares about the long division? I don't care about the long division. All I care about is the remainder. There There it is. So what is the remainder of this guy if I were to divide it by x plus 2? So could I use long division here? Yes. Could I use synthetic division here? Yes. And if I want to do it the long way, I could do it. The short way is I'm going to plug in what? I'm going to plug in.
Wait,
So,
since it's x minus k,
so here's a few things here. X minus k.
wouldn't that be x minus -2?
Yeah, and it works the same way, guys. Look at this. If you were to solve this guy for 0, notice you get your x is equal to k. So if I were to solve this, and I'm not sure why the books don't ever talk about it here. If I were to solve this, my plug-in value is -2. So can we quickly, guys, can we plug in a -2 into this?
Why is it all minus?
Because it's,
How are we able to identify if 2 is k of the preceding function?
sure. From our definition right here, it says your divisor is x minus k. Your divisor here is x plus 2. So notice there's a difference in signs. Or what you could do is just solve it for 0.
So what I'm asking is how do we know 2 is the k of x within exercise 7? Is that just implied due to the nature of the problem?
Yeah, just nature of problem saying that this is my divisor right here.
Okay.
So if f of x is being divided by x minus k, then we plug in the k. Okay.
Talked about finding the remainder of
Thank you for bringing that to me.
I'm gonna just to bug Abe a little bit here. Abe, -2 times -2 times -2.
that's going to be -8.
Thank you, Owen.
No, that's right.
-2 squared. Thank you, Maddie. 5 times -2. Thank you. I love it. I love bugging you guys here. Gives me a sense of purpose here. Camille, -24 plus 32.
I don't know. Wait, no, wait. It's gonna be,
Almost there, almost there.
yeah.
8 is perfecto. 8. 8 minus 10 is -2.
Yes.
Oh, who else can I bug? Charlie. 8 minus 10. And Tristan. Thank you. Did we know this already?
Yeah.
Absolutely. Let's go back in our notes. Boom, boom,
Why are we
boom.
doing the same problem like
Boom.
5 different times?
Showing you here. So this was the
Why
long
can't we just do
division.
it the easy way?
And we just did the easy way.
The
Look at
easy way
this.
is the way I can do.
Oh, I don't think so.
Long division?
So right there, that little -9 is there. When we get to 2.5,
Everyone should know that.
one second. One second. When we do 2.5, we're not going to care about the long division aspect of it. I only care about the remainder. We good? And then, surprise, we'll see. So synthetic division, I think, is easier to do. Yep, because there's less stuff to write down and then you do it. Plus the word long kind of implies a certain thing. Okay, so let's do just one more real quickly here. And Lynn, go ahead, talk to me
You
here.
said at the beginning of the lesson that we were going to be learning something that would carry over into future work.
To
Was that the
2.5.
remainder?
And the
Okay.
factor theorem, the other two
Gotcha.
things here. Okay, we got remainder theorem to work through and something called the factor theorem to work with.
My question is, why, like, are we gonna plug any numbers in for X, or are we just solving these because?
We are plugging in stuff and you kind of just learning how to divide polynomials. We're sort of like, we're doing, hey, let's divide polynomials and things that come out of it. And then at 2.5, we're gonna put it all together. Okay, how about this one here? Exercise 8. I'm gonna,
Oh, if you do that, I'm going to.
all right, all yours here, go. Find the remainder if 9x cubed minus 18x squared minus 16x plus 32.
Wait, is it just the same problem that we did earlier?
Maybe. Uh-huh.
Exact same numbers. Oh, we're dividing it by five.
X minus 2, by the same thing. The remainder is 0. Yeah, let's prove it.
Wait, were you right?
Well, yeah, of course I would be right.
Did you just guess right?
No,
We
we
did the
did
problem.
it before.
Oh, okay.
And so all we gotta,
I thought.
yeah, all we gotta do kind of just is think about this guy as f of x, right? This is a function. What do we plug in? A positive 2, good. Plug it in a positive 2.
See, there's the 9. Wait, no, where'd that 9 come from? What is going on?
Listen, you might know.
Yeah, but that was going on. No,
Two
there's
squared
two
is
problems.
4. No, that's cube. That's 8.
No,
9
no, no,
times
no,
8 is.
Wasn't that the problem? We got in the remainder of -9.
No.
That's the other one.
This is if this whole piece right here,
Brain hurts. Yeah, it's 0.
okay.
I don't do that.
Seventy-two
Go.
minus
Uh-huh.
32 Minus 32 plus 32. That's so messed up.
What is that? Is that 72 minus 72?
Yeah.
Minus 32 plus 32?
Oh,
Voila, 0.
That annoys me. Unlike this.
That is so cool though.
Real level?
So hold on. You guys talk to me here. If that is the case, oh, hold on, let's see. If I get a 0, we can do the next term. Let's put it, now let's put this all together here. It's called the factor
wait, like a factor?
theorem.
Oh, I need here.
So next and final theorem for today, the factor theorem. It says this. If
No, this is algebra. on
F of
steroids,
X.
According to Amanda.
has a factor, x minus k,
In the actual algebra, there was no K, math was easy.
You had X and Y.
You realize it doesn't matter what the variable is, you can switch, you can make all the k to y. All the
What
x's
about
you can make that.
Okay, sorry, the lone sandwich.
if f of x has a factor x minus k, that happens only if f of k equals 0. So now it's connecting this. If you get a remainder for the 0, you know that the x minus k is a factor of it.
Yeah.
So let's do this here. Let's
That's
put,
like super the obvious factor of the equation.
It's like geometry.
No, it's not.
No.
Shut up.
6 and 8 together. Yeah, so let's put,
How
How about this? We're gonna do exercise 6 and 8. We're gonna put those together. And then we'll do a problem all the way through here. So, some of them are from the textbook, some of them are from homework.
I think usually he takes the
He
easy
starts
one.
right
I usually, yeah, for example purposes, I usually take the even ones from the homework.
Oh,
They're similar.
Are you going to odd?
And then the odds are for you guys. Yeah.
No.
Okay, let's put it together since we have a little bit of time left. So first things first, when we're dividing 9x cubed minus 18x squared minus 16x plus 32 by x minus 2, did we get a remainder of 0?
Yes.
Yes, okay. We got a remainder of 0. That means x minus 2 is a factor. And what factor means is it was able to be factored down. That's what it means. So if we put all this together, now we can say this. We can say 9x cubed minus 18x squared minus 16x plus 32 is the exact same thing as x minus 2 times something. What is that something?
times
Just
3x
solve
plus
this.
4 times 3x minus 4.
Oh, hold on, yeah, hold on. This, it's that division right here. Wasn't this one right here?
That's the perfect difference of two squares. There's no difference of something where it's like the 3x plus 4 times 3x minus 4.
Uh-huh. Yeah, we'll get there in just a second here. But we got a remainder of 0, is that right? Was it easier to do it by synthetic division or just plugging in the value? For some people, it could be synthetic. For some people, it could just be plug in value, right?
Synthetic is very nice.
Mhm.
Wasn't this just ramifications
I
of
love
four
it.
is
It's
not
like my
real?
new favorite thing.
Therefore, we shouldn't be in it.
So let's do this here. Since this is the stuff that's left over, 9x squared minus 16, that's what's left over as my factor, 9x squared minus 16.
Yeah, that's cool.
Now, once we get down to, oh, hold on. We start off with an x cubed, right? Now we've got down to x squared. Now, once we get down to x squared, it's magic because we could either use factoring now, or if we're stuck, we can use quadratic formula. We good? So notice what we did here. That's this right there. What I can do now is to say, you know what? I can factor this down even more. That's just going to be 3x plus 4 and a 3x minus 4. Everybody agreed? That whole big weird thing, 9x to the cube, blah, blah, blah. By doing this little process, finding that little remainder of 0, we're able to factor it down and done.
If that number were to be on the test, would you want to write it, would you want us to write it fully factored like that? Or leave it with as a square?
Fully factored, let's do the big problem here. So the exercise 9 is kind of putting it together here. Exercise 9.
Okay, so just to
But
make
that's
sure I got this right.
Yeah. Yeah, sure.
If f of x is factor x minus k, only if
Uh-huh.
the remainder of f of x is 0.
Yes, correct.
So it's not the remaining.
F of k is equal to 0.
Oh,
F of k is equal to, yeah, as you plug it in.
So wait, the remainder or the result?
If the remainder is 0.
If the result of f of k is 0, then the remainder of the original problem
Is also 0. Those two.
Everything's 0, then it
Yeah.
has to be 0.
Yep. Thank you, Dylan. Thanks so much for clarifying it. Absolutely, because I really want to make sure you guys have got it here. So real quick here, let's go with it. Use synthetic division to show that x minus k is a factor. Then factor completely. Sorry guys, it's a little chicken scratch here. Can I read it for you guys? Use synthetic division to show that x minus k is a factor. And then after that's done, can you then factor down the rest of the way? I'll probably need to do 2 of them here. Okay, and then I'm going to put some missing stuff in here too. Here, so let's see how this works here. So here it is. F of x is equal to x cubed minus 28x minus 48. That's my polynomial. And then over here, x is equal to negative 4. So that's x cubed.
K is negative 4, right?
And that's a minus.
Yeah, huh?
Because the factor is x plus 4.
Mhm.
So k is still 4 then, right?
So let's see, the way we think about it here.
Opposite.
Yeah, negative, so if x is equal to negative 4, you know that x plus 4 would have been the factor, right? So just kind of keep that in your mind, boom. Okay, and then I want to tell you real quick here, it is missing x squared. You are missing x squared. So as we write this out, what am I going to put over here in front for synthetic division? I think I'm going to put negative 4. Negative 4 puts in for synthetic division. Good? Sorry, Tris, I know what you're saying. Yeah, 1. 1 is actually coming from the x cubed. X squared, what should we put for x squared? 0 for x and for the unit value. Boom. Add down, multiply up. Add down, multiply up. 1 comes down, -4 times 1 gets you -4, -4 plus 0, still -4, -4 plus 0 gets you 16, -28 plus 16. Who happened that I bugged yet? -12. And -4 times -12, I could do multiplication. Yep, and I like the little box. I like my little box for my remainder because it kind of sets it apart from everything else. Boom. Who haven't I bugged yet? I bugged this side of the room. Maddie, did I bug you already?
Ask Isabel.
I got it.
Alright.
I have the answer.
Okay.
Is it -96?
No.
For the remainder?
No.
Oh.
What?
Landon, hold on. Landon, what did you get for the remainder?
Of this?
Yeah.
I got 0.
Okay.
But I got a negative. Oh, it's a negative. No, what?
So sorry, let me check your.
Sorry, I plugged it in to all values. 64 minus
Negative.
I love
So-
that you get pointed out so quickly.
I love how excited you were about your
Tricky.
answer.
So because we know that it's the remainder of 0, let's see if this makes sense. That means that x cubed minus 28x minus 48 is equal to
72.
x plus 4. Okay, sounds good, man.
I love them. They were college kids and they're just having the time of their life.
So -12 comes down here. That's my -12. This guy's now my x value, right? So this is going to be -4x, and this guy is the term in front of x squared. Are we good there? Abe, are we good now? Cool. I have got it down to x plus 4. Now the question is, can I factor down completely now?
Yes.
Okay, and the answer is
I
x
don't
plus
know
4.
what I'm saying yes to. It's yes.
Yeah, here now it's just factoring. Two numbers multiply to -12.
X plus 2. Dylan, X plus 2.
6 and 2.
Well, ever since they came back, it's all
-6
wrong.
and 5.
-6 plus 2. So x minus 6, x plus 2, and perfecto. Are we good?
Yes.
That is cool. Look at that. We actually factored something that there was no way we knew how to factor that earlier, right? X cubed and then
So
missing
it's
the x
not
squared.
96. There's no 96.
No 96.
Nope.
No problem.
Okay, one more, of course, more difficult. Here it is, exercise 10.
I'm not good.
Can I just write down the problem itself here for you guys? Here's x cubed plus 2x squared minus 2x minus 4 is my polynomial. And x is equal to the square root of 2.
Oh, no.
What have you done?
What?
Could you say from the beginning, like?
Yeah, sure. X to the third power plus 2x squared minus 2x minus 4.
You can't have a negative square root on 20. You can't negative side square.
So,
Doesn't this not work? 'Cause does that make x not linear?
Correcto. Hold on. Sorry. No, I'm sorry. Just kidding.
And my,
Like,
I say
so
my
X-
laws back.
that's still a linear form, right? Because it's the x not having the square on it.
Four, oh, are you okay?
No, I was right on you.
Oh,
How do you get the square root of 2?
don't, hold on, wait. You're gonna wanna hear. it.
He's about to blow us, blow our minds with
What?
that.
we're just trying to factor this.
Uh-huh.
This is way too.
So we're dividing
Is
it
there any way we
by.
can like
The
negative
answer is
square
0.
everything
Answer is not. Well, it might be 0.
Yeah, let's just go with 0.
Should I keep it? Don't have enough time to finish. Should I keep it as a cliffhanger?
Yes.
Yes.
That would be
Yeah, I don't wanna
fun.
do that right now.
Like, hey, how's it gonna happen?
I'm mystified. So great.
I get to go see my dean. Oh, did you hear? Miss Shotwell was talking.
All right, you guys have enough. You guys do have enough.
I was gonna die in class. I went,
Thank you.
You guys do have enough information to do chapter 2.3 homework though,
Yeah,
okay?
thank you.
So you got,
They don't mention the whole square root thing.
besides the square root, yeah, that's the last problem on the homework here. Last or second to last? Yeah, second to last problem on the homework.
Thank you.
You got it. Bye, guys. Enjoy the rest of your day and the weekend.
I have a question.
Yeah.
So I wasn't able to
Bye,
find
Siva.
2.1 submission form. I don't think I'm enrolled in algebra semester 2.
Sorry, I totally forgot to mention here. So I have to create the Google Classroom for semester 2.
Okay.
That's why. So as soon as that's created, I'll send you guys a link and then you guys can get in.
Okay, sounds
Yeah,
good.
that's
Thank you.
totally my fault. Yeah, I was trying to do it on Wednesday night thinking, oh, hold on, no, I need to create a whole new semester. That's my
Oh, yeah.
problem. So totally forgot to mention it. Mhm. Yes,
I
sir.
apologize, but due to the yammering of certain